Okay, so continuing with the notes for today, we see that we have different types of instruments. So a voltmeter measures the amount of work done as electrons move between 2 points. So again, we're going to use the digital multimeters to measure the voltage, current, and resistance. So we're going to see that in electricity, a lot of the units are named after scientists that contributed and made significant discoveries. So Michael Faraday, he was an English scientist, and he made the first electric generator. So when we talk about capacitance and the unit of capacitance is a farad, which is named after Michael Faraday. So again, a lot of the units of electricity are named after scientists. So what is a capacitor? A capacitor is an electronic device. So it's a combination of conducting plates separated by 2 layers of dielectric. That means an electric insulator that's non-conducting, that's used to store an electric charge. So a capacitor, basically in layman terms, it stores electric charge. Okay. There's different size capacitors. You see capacitors in all different types of electrical components. And when we get to Chapter 18, we're going to actually look at these different types of electrical components. So we want to calculate the capacitance, again, the ratio of charge on either plate and the potential difference. We see that capacitance is equal to the magnitude of the charge on each plate divided by the potential difference. So C is equal to Q over delta V. And here's an example. It says a sphere has a potential difference of 60 volts. So again, potential difference, the symbol is V, and the unit is voltage. So I'm going to put that in my given. When charged with 3.0 times 10 to the negative 6 coulombs, so I know that's charge because it's measured in coulomb. What is its capacitance? So C is Q over V. A lot of times I don't put the delta in. The delta is there because the delta means the change in. Okay, but just like in the beginning of the year, sometimes with the equations, it makes it easier to remember if you just know that the delta goes there. So 3.0 times 10 to the negative 6 coulombs over 60 volts, and a coulomb per volt, that's a farad. Now, normally, because capacitance is small, a lot of times it might be measured in a microfarad. And remember, micro means 10 to the negative 6. So another example, it says a commercial 5.5 times 10 to the 1 microfarad capacitor, so that's C, has a potential difference of 25 volts across it. That's V. What is the charge? So now I want to find Q. So C is equal to Q over V. I rearrange the equation to solve for the unknown in terms of the known. So Q is equal to CV. Substitute in my values and solve. And that's it.